This one, like the previous problem, is being rotated about the y-axis. The region is 0 to 1. It's the cube root function. So from 0 to 1, take this arc right here and then rotate it about the y-axis. What is the surface area that's created? Well, we're going to need to know the arc length, so for that we need the derivative. And the derivative of y, let me rewrite it over here, y equals x to the 1/3. Then the derivative is going to be 1/3, subtract 1 from the exponent, and we get x to the negative 2/3. And then I don't like to work with negative exponents, so rewrite that as 1 over 3, and then x is to the 2/3. Since it's being rotated about the y-axis, then the radius, which is measured from the axis of rotation out to the object, this is the length of x. If we were rotating instead about the x-axis, then you go from the x-axis up, and then the radius is the function. Since it's going sideways, it's the value of x. So we've got surface area integrate on the interval from 0 to 1, 2 pi times the radius, which for this is going to be x, and then times the arc length. So the square root of 1 plus this being squared. So 1 plus 1 over 3x to the 2/3 is being squared. And then we need to do some algebra. When you square this thing, well, the 3 will become a 9, and then when you have a power raised to a power, you multiply, so this is going to become a 4/3. I'm going to go ahead and factor 2 pi out right now. So we've got the square root of 1 plus a 1 over 9x to the 4/3. Well, there's not a lot we can do as far as u substitution or anything like that with this mess, so what we've got to do is combine it and get these two fractions to become 1. So this is going to have to become 9x to the 4/3 over 9x to the 4/3. And then add the two together. So now we've got one big fraction that has 9x to the 4/3 as its denominator. For the numerator, this would add a 9x to the 4/3 plus this single 1. Now it turns out that this you can take the square root of, so this is going to become a 3. Square root, well, that's the same as a half exponent, so it's going to cut this in half and make it 2/3. So the radical still applies to this thing, 9x to the 4/3 plus 1 over, so simplify this one, and the denominator is now just a 3x to the 2/3. And then we can do some more algebra, like we can take this 3 and factor it out, so this becomes 2 pi over 3. And then this and this, if you combine them, leaves behind x to the 1/3. So we now have 2 pi over 3 on the outside. Integrate. These two become an x to the 1/3. And then we have the square root. What fun. Even better than watching TV. Next, it's ready for u substitution. So this part right here is going to be the u. So let u equal 9x to the 4/3 plus 1. Take the derivative of that, and we would get, well, let's see, the 3 would reduce, so this becomes a 3 times 4 is 12, x to the, now subtract 1, and lo and behold, it becomes x to the 1/3. So our problem has x to the 1/3 dx. Our u substitution says you need exactly that. This 12, though, we'll have to multiply both sides by 1/12 to cancel that. And then it's ready for the u substitution. So this 1/12 needs to be moved over here. So I'm just going to write it as the 12 is in the denominator, and then I'll simplify it in the next step. And then integrate, and don't put the limit 0 to 1 because now we're going to the u system. This is simply going to become the square root of u, and then du. Well, square root of u, that means u to the 1/2 du. So finally, after all of that algebra, it turns out to be a very easy antiderivative. This is going to become u to the, so add 1 to the exponent, it's 3/2, and then divide by 3/2. And then we need to transfer this over, so let's see, this is going to be a 2 over 36, which means 1 over 18. So pi over 18. And then in the next step, reduce even this, so 2 goes into 18 9 times, so now we've got a 27. So we've got pi over 27, and then replace the u with this thing. So 9x to the 4/3 plus 1 is raised to the 3/2, and now that we're back into the x system, you can put the limits 0 to 1. So when you substitute a 1, this is going to become 1 to the 4/3, so that's a 1. So 9 and 1 makes 10, and then to the 3/2. So pi over 27, and then 10 to the 3/2. When you substitute a 0 in here, it's actually going to be 9 times 0, so that's gone. And then we would just have 1 to the 3/2, which is a 1. So then minus that 1. And I've just factored the pi over 27 out completely. And then as a decimal answer, we would get, let's see, pi divided by 27, and then it's 10 is raised to the 2/3 minus 1 per m. So it's going to be pretty small, 0.424. But then again, we are talking about the cube root function, that is pretty small.